Okay, I think we can start. Katie, over to you.
Oh, good morning, everybody. Thank you for joining and registering for Simtek's inaugural webinar on Industry 4.0 and the Smart Factory. I'm Katie Harrison, the Marketing Manager for Simtek. This is the first in a series of industry-focused and technical webinars that will be hosted in the future. And I'll be sending invites to all of you on more topics that we plan to run one webinar a month. So this webinar is focused on Industry 4.0 and the Smart Factory and will be presented by Simtek's CEO, Ali Shihab. The presentation will last around 20 minutes long, and then there's an opportunity at the end to ask questions. If you want to ask questions, you can either use the chat function or you can unmute your microphone, and we'll answer any questions when we open the Q&A. So in the meantime, I'll mute your microphones, and then at the end of the 20-minute presentation, I'll unmute you. Thank you very much. I'll pass you over to Ali.
Hello, good morning. My name is Ali Shihab. I'm the CEO of Simtek. I've been with the company for 21 years. I founded the company in 1998, and we are a company focused on cable software. This morning, I'd like to talk to you about Industry 4.0 and its relationship to the smart factory. There are a lot of myths around Industry 4.0, and if you look in Wikipedia, it talks about cyber-physical systems. Now, who knows what cyber-physical systems are? They're sort of monsters that come and eat you in the night if you really think about it. On the other extreme, you have technology companies that are painting a picture of the future that is so bright, it's mythical. And I call those technical extremists. So they project the future which nobody really believes in. The truth is somewhere in the middle, and it's not going to eat you, and it's not going to be the bright lights of the future, but it is about efficiency and manufacturing excellence. Okay, so some of the things that people have talked to me about, so Industry 4.0 and Internet of Things and Smart Factory are the same thing. Well, no, they're not. They're not the same thing at all. I've seen pictures where a smart factory has predicted as an overlap between Industry 4.0, MES, and Internet of Things. Well, again, that's not quite right. But in order to understand how Industry 4.0 fits together, we really need to go back to what Industry 3.0 was. And Industry 3.0 is about effectively two things that are separate. It's about technology, and it's about methodology. So technology like automation, we've seen in the cable industry a lot of diameter controls, light controls, about robotics, about the technologies that we had 10 years ago and before that. And the methodology is lean. There are other methodologies, but lean is widely used in the cable industry, and it is a quite an effective way of improving the manufacturing process for cables. So if we now look at Industry 4.0, Industry 4.0 is really the same thing. So you've got a collection of technologies like Internet of Things, like cloud computing, like artificial intelligence, like MES, and the smart factory is what brings them together. So the smart factory is the theory, if you like, the methodology. And we will talk about that in a little while. Okay, so let's just talk about those technologies that Industry 4.0 bring us. So things like cloud computing, 3D printing, artificial intelligence, big data, where we have a huge repository of data that we can you can use and analyze and use it to instruct people what to do or suggest to people what to do. You have digital twinning. It's a curious name, but it's what it means is simulation of either a process, a manufacturing process, for example, or a product in a world, to test things through it, to make sure that things work before the physical thing is made, or before the physical thing is put to the shop floor or sent to the customer. The people who use, for example, Cable Builder for design, it creates a digital twin, both of the factory and of the product. Internet of Things, we'll talk a little bit more about that, and then you have various other things which are not very prominent in the cable industry, like robotics and virtual reality, etc. So these are the technologies. There are more, of course. These are the technologies that are Industry 4.0. In order to understand the smart factory, what I'm going to do is I'm going to go through what we called the integrated factory. And that's, we talked a lot about that in the past few decades, about the integrated factory. So what does that mean? The integrated factory is a collection of different processes, different systems that are normally depicted in this pyramid. And as you're going from the bottom of the pyramid to the top of the pyramid, you have a lot of data at the bottom, and then the data gradually gets less and less and less, and information and data now is turned into information as you are going up the pyramid. So we've got the devices on the machine, you've got the sensors, you've got the programmable logic devices on the machines, collecting data from the sensors and the actuators. And then you've got SCADA, which are a human interface on the machines to control the machines. You've got planning systems and MES controlling what is to be made on the shop floor. Then you have ERP, who's controlling the business, and you have CAD and cable design software, etc. at the top, which is systems that create designs, quote customers, etc. So data flowed in generally one direction, actually two directions. So instructions came down to the operators, and data went up, but normally it stops somewhere, big data if you like, stops somewhere around here. Okay, so what does that mean in real life? So you have a customer who asks for a quotation, and a design system is used to quote a customer. Once a customer is happy with their quotation, they place an order in an ERP system or through the sales department through an ERP system. An ERP system, enterprise resource planning, it generates, has a look at see if materials are available. If not, they get ordered. If they are available or when they're made available, then a production order is generated, and a production order is then sent to the manufacturing execution system, and the manufacturing execution system controls the workflow on the shop floor. The jobs then go from the manufacturing execution system to a SCADA, and SCADA, I can't remember exactly what it means. It was in the old slide if you want to go back. It's a human interface on the machine, so it will possibly have recipes for the product, the job information, information from the machine itself, from the sensors. It's able to control actuators and motors and drives, etc. So once it's in SCADA, the recipe it gets downloaded to a PLC, and PLC is basically an industrial computer that is inside your machine. And the PLC will instruct the machine to set up for that batch of production. So it will set up all the temperatures for the extruders. This will instruct the drives have to ramp up to achieve minimum waste, etc. So as the production is going through, the cable is being produced, the sensors, for example, here we have a length counter. That data is sent back to the PLC and sent back to your SCADA. Once a job is complete or there's progress on a particular job, that is sent to MES, so everybody on the shop floor knows about it. When an order is complete, it's sent to ERP system. to tell it, yes, okay, it's now ready. ERP will then arrange for dispatch and then further invoicing and further financial transactions as well. Okay, so if you are a visionary and you have this is your vision to create an integrated factory, that is how you create an integrated factory. So you have all these systems talking to each other, and that's great. It works really well. Now, if we're looking at the smart factory, so what's the difference between those two? A smart factory, let's look at the theory first. So the theory is a smart factory has to be communicative. So communication between workers and machines, communication with the customers and suppliers. So there's a lot of communication going on here. The smart factory needs to be adaptable. So it has to adapt to its own environment. It has to adapt to, it has to learn from its own environment, and it has to change according to its environment, according to to what's going on the shop floor, for example. It has to be collaborative, so machines, for example, can talk to each other and will say, well, okay, I'm here, I'm a bottleneck machine, I'm completely loaded, I need to instruct machines downstream to slow down or even stop. One is if they slow down or stop, then we're reducing work in progress, reducing inventory, saving money. Also, by slowing down machines, you are guaranteeing better quality product. So there is a balance, but the balance needs to be devices on the floor, the processes on the floor need to be intelligent enough to communicate to each other and collaborate. Okay, in order to achieve all of this, what we actually need what we have now in the world of a smart factory is the value of information. The information is much more valuable than it was in the integrated factory. So in the integrated factory, we saw that a length information goes through the PLC, goes through the SCADA package, goes through lots of system and gets changed before it gets to the ERP system, to the customer, or to anything. In the world of a smart factory, that information can be used directly by various different components in the business. So it can be used by an ERP system to tell it when its order is complete. It can be used for ordering material, not necessarily from the supplier through shipping, but from the warehouse just in time. So when something is about to finish, the material is ordered, so there's no clutter on the floor. It can be used to improve the design of the product. Many examples. So length information can be used to determine what is the current efficiency of that product, so that it can be costed properly, it can be planned properly. We can use various other feedback to improve the product tolerance, etc. We can use the same length information to improve the machine. So via OEE, for example, via various other methods. There's a feedback to the machine itself. There's a feedback from the length counter, for example, to the machine manufacturer to tell them, okay, how efficient is that machine working? There are various what we called a dashboard events that happen. So whenever there is a short length is produced, that is alarmed, and people on the floor know about there's a short length that's been produced, so they know what to do about it. Maybe talk to the customer, maybe put it in storage, maybe quarantine it. So there is immediate impact. And information from that device is producing. We can talk to the customer, so the length device can talk to the customer to say, okay, your order is due then because I've just measured it and it's up to that stage. And when the length is complete, or just before it's complete, a dispatch is ordered, and maybe a forklift truck is available just as the cable is being dropped off the payoff and goes on the truck, and it gets dispatched. So what is happening here is a piece of information is a lot more valuable in the world of a smart factory. That does two things. It's actually can be used and improve the process and to improve the decision making throughout the factory. So we no longer wait for analysis to come from reports that are generated at the end of the week, end of the month. We have dashboards in these different processes, and the dashboards tell us immediately if there is a problem, so people can make quick decisions and with high quality, based on high quality information immediately. So that's really what it is about. Okay, in order to do this, in order to achieve this what we call democratization of information, we no longer can have a device connected to another device, connected to another device, and information flows through a chain, through that big pyramid that we saw earlier. What we need to do when we're talking about implementing a smart factory is to have a platform which, let's call it the Industrial Internet of Things platform. There are many on the market. We use Wonderware system. We use Wonderware system platform to connect devices and connect them to processes. So what is happening here? So you've got devices connected to the IIoT platform. You have systems like the design systems, like ERP systems, etc. And they communicate with each other. So if an MES needs length information, it goes to the length counter, does its thing. If the ERP needs length information, it goes directly to that. If an ERP wants to know, or the customer wants to know if there are any faults that have happened on this on this batch of cable, they acquire this particular layer. And this layer does many things. It has collectors to collect information. It has what we call big data in the form of historian. It has redundancy because this data, this layer is now really, really important, and every communication goes through it. So there's plenty of redundancy in there, so you're not stopping the factory if something goes wrong. Then you have the APIs, which can connect to different systems and various other things in the real world. So that is just taking the integrated factory and forming it into a smart factory. The other thing which does happen is there are the new technologies like machine learning. So that can also connect to our Industrial of Things, Industrial Internet of Things platform, gets its data, and it can help people in various parts of the factories to make decisions on whether this design is the correct design for this particular application, whether this is the correct recipe for this particular process, etc. You have 3D printing. We are already 3D printing things from cable builder, for example. So 3D printing of and visualizing complex products. You also have smart assets that are coming on the market, and you have smart extruders, and we'll talk a lot about that in a second. So this is the vision, if you like, of a smart factory. So the smart factory is decentralizing information, making it available to every process in the factory. And then the processes in the factory have to have those attributes of communication, adaptability, and collaboration. Okay, a little look at a smart asset. So an extruder, for example. There are many extruders that are coming on the market now, wire drawing machines, etc., which exhibit those attributes of smart. So they are communicative. They communicate to the supplier. So they tell it the performance of this particular extruder for this particular material for this particular product. Then the extruder manufacturer has all this big information, big data, And from that, they can look and see, well, okay, how can we improve this this extruder? So they will go back, analyze it. Maybe there is some sort of change in the temperature profiles I need to make, maybe some mechanical change. And some of this can be downloaded automatically to the extruder. So the supplier doesn't need to be on your floor to analyze the data. Data goes to them, and that data comes from multiple factories, so they know exactly how this extruder is performing. We see a lot of recipe-driven product manufacturing now. So the recipe can be changed again based on the feedback from previous runs of the extruder. So these assets are now becoming more and more available. These assets also communicate to systems like MES to manage the flow of product between processes as well. Okay. Just don't be complacent when it comes to implementing a smart factory. A smart asset does not make a smart factory. So you can fill your factory with these smart assets, but it's not the assets that are going to make it smart. It is the factory itself has to be smart. So it has to have the ability to communicate, adapt, and collaborate. And when we're putting a strategy together for a smart factory, that's what we need to bear in mind. And that needs to happen between processes in the factory. Okay, with every technology, with every change, there are threats and there are things that could go wrong. With the smart factory now, we are relying quite heavily on information and communication. So cybersecurity needs to be quite tight. You need to have plenty of policies. You need to have plenty of redundancy. You shouldn't create or analyze if there is a single point of failure. So if you have a single point of failure, you need to somehow get around that. That is to make sure that the factory doesn't stop, because it is very expensive. The other danger is because of how information is used. So a single piece of information is now much more valuable. That information has to be right. If it's not quite right, it will not. It will break processes, and it will break not just one process, probably many. So you need to make sure that things are tested and approved before production. Okay, so what's the conclusion? The conclusion is smart assets are here, and please do use them, and they make sense. The smart assets not necessarily just extruders, but you've got MES systems that come with Internet of Things platform. You've got various other things then. So they are here, please use them. And you'll need to start working on a smart factory strategy. Because everybody is, and that's really important, and it's moving from or changing from the vision from the integrated factory to smart, where it is more a proactive approach. So you have dashboards that tell the operator, or tell the supervisor, or tell the factory manager something has gone wrong. Do something about it now, rather than waiting for analysis reports. And it is disruptive technology. So, and you need to be disruptive, and you need to embrace disruptiveness. Of course, you need to control the risk of disruption, but it is disruptive. And it's always, in order to gain advantages, if you do the same thing, you get the same results. So to move forward, you need to be disruptive, and you need to change things. Okay. With that, I have concluded my presentation, so it's over to you for any questions. We have a quiet audience, so I can't see or hear any questions. So over to you, Katie.
Okay, any questions from anybody an opportunity before we close the webinar. I've unmuted all your microphones, so nope. Okay, thank you ever so much to everyone for attending today. If you want any more information, please visit simtech.com, or you can email me on katie.harrison@simtech.com. A recording of this webinar will be available, and I'll be sending it out to everyone who's registered. And thank you very much.
Thank you.
Thank you, Katie. Thanks, Ali.